So for question 1, we are asked to find how many rubber balls fit into a tube of a certain size. For questions like these, it's usually hard to tell what you need to work out. So the best thing to do is write down what you're told or what you know, and then try and figure out what we want to know and how we can use this. So I've started by writing down the density and the mass of the rubber balls, the tube height, and my question, how many balls fit into the tube. I've thought about it and thought, what do I actually want to know? Well, to figure out how many balls fit into the tube, I want to find out the height of each ball. I also know the mass and the density of each ball, so it's likely that I'm going to use these to figure out the height of each ball. So I've started by writing down the formula I know that involves density and mass. So density is equal to mass over volume. And I also decided to write down the formula for the volume of a sphere, because obviously we're not given any of the volumes here, and it's okay to look this up if you're not sure about it, but the volume of a sphere is 4/3 pi r cubed. Now I've had to think about how this relates to the height of my ball. Well, I know that the radius of the sphere is half of the diameter, and I know the diameter is the same as the height of the sphere. If you go from one point of the sphere to the other point of the sphere, that's going to be the height and also the diameter. So what we actually want to find out is the radius of each ball. Now that I know what we're actually looking for, it's easier to figure out what equations I'm going to use and how I'm going to use them. So I want to find what R is equal to. I know my density and my mass, but I don't know my volume. So what I'm going to do is to substitute my values into this equation, density equals mass over volume, and solve for R. So in terms of density, I've written 1.7 because I know the rubber ball has a density of 1.7 grams per centimetre cubed. In the place of mass, I've written 450 because I know that the mass of each ball is 450 grams. And then in place of volume, I've just written the formula for my volume here. We can see we now have an equation just in terms of R. So the only unknown variable in this whole equation is R here. All of these are just numbers now, including pi, which we know is 3.14. So then we're going to use our rearranging to solve for our unknown variable R. So in each step, I'm just rearranging as I normally would. So I'm dividing 450 by 1.7 and then evaluating this to a number so that it's easier to figure out after I do this in the calculator. I'm then going to divide by 4/3 pi, because obviously 4/3 pi is technically just a number. So I then put this back into my calculator to evaluate again. And finally, I have R cubed is equal to 63.1939. So I'm going to cube root this number to give me R. Now, all of this has been put into a calculator at each step, and I get my answer of R is equal to 3.983 centimetres. But obviously, this is not the last step, we've just found our radius. So now that we know our radius, we can say that the diameter is obviously 2 times this, which is 7.966 centimetres. So this is the same as the height of each sphere. The tube is 750 centimetres, and note that obviously we were given that the tube is 0.75 metres, but I've put this back into centimetres because we have the diameter of each ball in centimetres. So it's no good to us to have metres and centimetres, we want it all in the same units. To find out how many balls go into the tube, I've divided the height of the tube by the height of each ball. And this has given me a value of 94.15. Now obviously balls are real objects, you can't have 0.15 of a ball, so I've rounded this down and said that 94 whole balls fit into the tube. So for question 2, I've started with doing exactly the same thing as question 1. I've written down everything that I've been told in the question. I've written down what I want to know, which is the volume of the small model or the small statue, and everything that we do know. Now, I thought that because we've been given the mass, the density and the height of the big model, it's likely we're going to need to work with these numbers first before moving on to the small model. Now, because we know the mass and the density and we're trying to find volume, obviously we're going to use this formula again, density equals mass over volume. And I had a look and I saw that obviously we know the density of both of the models, but we only know the mass of the big model, which I have converted into grams here because obviously our density is in terms of grams, we want it all in terms of the same units. So like with the previous question, I've now substituted the values I do know into the formula to find an unknown. So we know that the density is 2.5 grams per centimetre cubed, so I've put that in here. I know the mass is 4,100,000 grams, so I've put that in here. And I've given the volume of the big model the variable VB to tell me this is the big model, not the small model. I've rearranged this, it's only one step luckily, and I've found the volume of the big model is 1,640,000 centimetres cubed. Now this was interesting because initially I thought, how am I going to find the volume of the small model? I've been given the height of the small model and the density of the small model, but how am I going to find the volume just from the height? I don't know what 3D shape it is or how to calculate this. And then I thought, why would they give us the height of the big model if we haven't used it in here at all? This is the one thing we haven't used yet. Now, they've given us the height of both models, and so I realised we need to assume that obviously they're made in exactly the same way. So the big statue is 200 centimetres, and the small statue is 8 centimetres. So if they're made in exactly the same way, we can say that 200 divided by 8 is 25, which means that the big statue is exactly 25 times bigger than the small statue. Because they have exactly the same density, I can use this to figure out the volume. So, I have the volume of my big statue here, and I've divided it by 25 because obviously the small statue is 25 times smaller than the big statue. And this gives me the volume of my smaller statue here, which I've put as VS is 65,600 centimetres cubed.